Okay, ladies and gentlemen, I now want to talk about the benefits of using scientific notation. I've already shown you how to write numbers in scientific notation. Now I want to talk about why you would do so. So, one reason is that it allows us to write really big or small numbers in a shorter form. This is what most teachers tell their students that we use scientific notation for, and it's true, it is a benefit. So here's an example. Here I have 35 billion. But I can write that in scientific notation by writing one significant figure in front of the decimal, the rest of the significant figures after the decimal, and multiplying by an appropriate power of 10 to make it equal. So here I would have to multiply by 10 once, 4 times, 7 times, 10 times. So this is 3.5 times 10 to the 10. We can write it in a shorter form. That also works for smaller numbers. We can write one significant figure in front of the decimal, the rest of the significant figures after the decimal, multiply by an appropriate power of 10. So in this case, negative 1, 2, 3, 4, 5, 6, 7. So the first benefit is it allows us to write long numbers, big or small, in a shorter form. The second benefit is it simplifies calculations, particularly when you do them by hand. You can multiply these out in standard form and get the answer, but it's much simpler to do so once they're in scientific notation. 2 times 3.5 is 7. 0.1 times 3.5 is 0.35. So 2.1 times 3.5 is 7.35. 10 to the 10th times 10 to the negative 7th, we simply add the powers. 10 plus negative 7 is 10 minus 7, so that's 10 to the 3rd. So you can do this very easily in your head because it's in scientific notation. Now, to follow our significant figure rules, both of these have two significant figures, so we should round this so it has two significant figures. Here's the first one, there's the second one, and I'm going to round that up, so I get 7.4 times 10 to the 3rd. Both of those are great, but the real reason that we use scientific notation is this. It allows us to show the correct number of significant figures in a situation where standard form cannot do that. So let's look at an example. Let's say I'm finding an area, and I have a rectangle with a length of 125 centimeters and a width of 20 centimeters. I can multiply out to find that area. 2 times 125 is 250. So 20 times 125 is 2,500. Centimeters times centimeters is centimeters squared, or square centimeters. Now let's think about our significant figure rules. This measurement has 3 significant figures. This 0 is significant because it's after a decimal. This 0 is significant because it's included between things that are significant. So here we have 3 significant figures. Here we also have 3 significant figures. So by our multiplication rule, we should round our answer off to have 3 significant figures. So we should round to the tens place. Well, it's already rounded to the tens place, but the way I have it here, these trailing zeros are not significant. This only shows 2 significant figures. We need to show 3. Well, you might think just add a decimal at the end. But if I do that, both of these become significant, and now I have 4 significant figures. So in standard form, I can either show this as 2 significant figures, or I can show it as 4 significant figures. But I can't show what I want, which is 3 significant figures. And this is the real benefit of scientific notation. If I take this number, I want these 3 digits to be significant. I write 1 digit in front of the decimal, the other 2 significant digits after the decimal. I now have 3 significant figures. This 0 is significant because I added it on purpose, and I can tell that because there's a decimal. Then I just multiply by an appropriate power to make this equal to what we had. And now my measurement shows the correct number of significant figures. So, in summary, scientific notation can make writing numbers shorter, can make your calculations easier, but the most important thing is it will allow you to show the correct number of significant figures when you otherwise could not.